right, so before today, we did Pythagorean theorem. If you had two sides of a right triangle, you could find the third, right?
Yeah.
But if you had one side, you're like, that's not enough information. Today, if you have a triangle that has a 30-degree angle and a 60-degree angle and a 90-degree angle, then you can only use one side and you can still find the other two without the use of the Pythagorean theorem. So it's called special because you don't need to use the Pythagorean theorem. You get to use inductive reasoning, which means we're going to learn a pattern, and you're going to use that pattern to solve these triangles. Okay. So you might ask yourself, where does a 30, 60, 90 triangle come from? If you look at your first sheet, when you open it up, where do they come from? They come from an equilateral or equiangular triangle. Okay? Now, we call it equilateral because all three sides are the same, but remember that means we could also, if we really wanted to, we could call it isosceles because at least two sides are the same. If you draw the altitude in an isosceles triangle, what does it do to the base? It divides them equally in half. And what does it do to this vertex angle up here at the top?
It splits it in half.
It also splits it in half, making the 60-degree angle up there how much? 30. Do you see two triangles that are 90 degrees, 30 degrees, and 60 degrees?
Yes.
Yes, that's where they come from. They come from splitting an equilateral triangle in half. So one half goes here, and one half goes here. So once you've done that, then you now have a hypotenuse in each triangle. And then you have two legs. And because one of your angles that's not 90 is smaller than the other, one's 30, one's 60, 30 is smaller, that means the side across from it will be a shorter side. So we give it a really fancy name. Are you ready for its fancy name? We call it the short leg because it's short. Okay? And then the other one across from the bigger angle, the 60-degree angle, is longer than the short leg. So guess what we call that one?
The longer leg.
The long leg. Okay? All right, so knowing that it comes from an equilateral triangle, if you next example on the next page, I have the 30, 60, 90 triangle darkened in, but I've also drawn the equilateral triangle that it came from, okay? So if the equilateral triangle originally was 24, what is the hypotenuse in this triangle?
24.
24. And then remember the altitude, that's the long leg, divides the base, the two short legs, in half. So how long is each short leg?
The same.
If all the way across is 24, how long is each short leg? 12. So the short leg is 12. Okay? So now I need the long leg. We're not going to use our calculators. Well, you can use your calculator today, but we're not going to have any decimals today unless we're dividing by 2 and it's a 0.5. Okay? So if I'm looking for the long leg, it's a leg. So that means inside my square root, add or subtract. Subtract 24 squared minus 12 squared. When you put that in your calculator, do it without the square root because I don't want to get a decimal. So just put 24 squared minus 12 squared. And somebody tell me what you get. Without the square root, I say.
432.
432. So this is the square root of 432. Guess what we're going to do to that square root? We're going to simplify it by using its factors. We want a factor that comes from our list. Okay? A big number that goes in there from our list.
64.
So in your calculator, try it. If you're going to yell it out, try it and make sure it works before you say it. 124 does not divide 432 evenly.
Ooh.
Yes.
144 times 3.
144 times 3. So I can change this into 144 times 3. So when the 144 comes out,
12.
it becomes a 12.
12 radical 3.
12 radical or 12 square roots of 3 is my long leg. Well, that's kind of neat. My short leg is 12, and my long leg is 12 times the square root of 3. Interesting.
Is that like, does that just happen?
I don't know. We'll have to do a couple more and see. Let's look at the next one.
Okay.
What is my hypotenuse on this one?
36.
What's my short leg? So then I need to use the Pythagorean theorem to find my long leg. Add or subtract?
Subtract.
36 squared minus 18 squared. 972? All right, I need a big number that goes in there from my square root list, or my perfect square list.
81 times 12.
81 times what?
12.
81 times 12. When the 81 comes out, what does it become? 9. 9 square roots of 12. Check the 12. Can that be simplified?
Yes.
Oh, what times what?
3 times 4.
4 times 3 or 3 times 4.
And then you bring it out, so then it's 18 radical.
So this comes out as a 2. So it's what?
18 radical 3.
18 radical 3 or 18 square roots of 3. Oh, look, it happened again. My short leg was 18. My long leg was 18 square roots of 3. Let's do it one more time for third time's a charm. All right. So if my hypotenuse on this next one is 18, what's my short leg? 9. So then my long leg, 18 squared minus 9 squared. What's 18 squared minus 9 squared? 243. What goes into 243?
9.
What? 81 times 3? So when the 81 comes out, what does it turn into?
9.
Oh, 9 square roots of 3. Do you think we can safely assume, using inductive reasoning, that that's going to be the pattern?
Yeah.
Yeah.
Oh, wait, it's doing radical 3.
All right, so look at the next one. We're using our math, right? We're using the pattern. So we're not trusting our eyeballs. We're trusting the math that we've done. Okay? What's the hypotenuse on this last one?
15.
What's my short leg?
7.5.
What's my long leg?
7.5 radical 3.
Perfect. 7.5 square roots of 3. Okay? If you look at the bottom of that tab, there's all the work we did. If you look at the bottom of the tab, it has the x squared of 3, and the 2x. The x is representing, and you might want to write this on the bottom of your notes right there. The x is my short leg. What is the x square root of 3?
Long leg.
Long leg. And what is the 2x?
Hypotenuse.
The hypotenuse. So the reason we write the short leg first is because if you know the short leg, all you have to do is stick a square root of 3 on it. You got the long leg. All you have to do is double it. You've got your hypotenuse. Okay? I am. Yes. Yes. All right. Given the short leg. So all of these, I'm going to start with the short leg. So when I look, I can see they gave me between the 60 and the 90 is my short leg. They gave me the 3. If that's my short leg, what's my long leg?
6.
3 square roots of 3.
3 radical 3.
What's my hypotenuse?
6.
That's the one that doubles. That's the 6. Okay, just 6. You just double the short leg. Okay? So again, to go from the short leg to the hypotenuse, all you do is multiply by 2. To go from the short leg to the long leg, you multiply by the square root of 3. Okay? So look at the next one. My short leg is 10. What's my long leg? 10 square root of 3. What's my hypotenuse?
20.
20. Okay? Now the next one's a little weird because my short leg already has the square root of 3 on it. So when I come over here to my long leg says take this short leg, the 4 square roots of 3, and multiply it by the square root of 3. What happens when I do 4 square roots of 3 times square roots of 3?
4 radical of 9.
Well, what is the square root of 9?
3.
It's just
And then you
3.
bring it out, and then 4 times 3 is 12.
12.
Is that all in your head? Yeah.
Okay? If my short leg is 4 square roots of 3, when I double that to get to my hypotenuse, what do I get? 8 square roots of... No, 3. Remember, your square roots only change if you multiply into them. Okay? If you're just doubling the outside number, it doesn't change. Okay? All right, so the next one's very similar to the one we just did. I've got a square root where it doesn't belong on my short leg. So my long leg, what do?
You times radical 3.
Yeah, it's the 7 square roots of 3 times another square root of 3.
So it's 21.
So it's 21. What's my hypotenuse?
14 radical 3.
14 radical 3, or 14 square roots of 3. All right, so let's go to the next one. All right, now we're back to normal. 15, our short leg is 15. So my long leg is 15 radical or square root of 3. And my hypotenuse is 30. All right, the next one, it's back to weird again. My square root is in the wrong place. It's on the short leg. What's my long leg?
36.
36, because it's 12 square roots of 3 times the square root of 3. 36. Do I need to write out the work?
Yes.
Yes?
No.
No?
No.
Yes.
All right, so 12 square roots of 3, square roots of 3. My square roots of 3 become square root of 9, which is just 3. 12 times 3, 36. What's my hypotenuse if my short leg is 12 square root of 3? 24 radical 3, or square roots of 3. Okay? All right, the next one, my short leg is 9 square roots of 3. What's my long leg?
8. Or sorry. 27.
27. What's my hypotenuse?
18 radical 3.
18 radical 3, or 18 square roots of 3. Yes?
I'm sorry, I just kind of noticed a little bit of a pattern when it comes to the short leg and the long leg.
Uh-huh.
If you just multiply the two numbers together, you'll get the long leg.
Perfect. Look at her using her inductive reasoning.
Congratulations.
Yeah, you just multiply the 9 times 3, that gets you to your 27. Perfect. So imagine, if you will, hold on real quick. What if the long leg, what if we were going to go backwards and my long leg was just 27 and I needed to go backwards? What would I do? Divide by 3. Okay? All right, let's do the last one. All right, my short leg on the last one is 14. What's my long leg? 14 square root or radical 3, What's my hypotenuse? 28. So you need to be real careful. When do you multiply by 3 and when do you just put a square root of 3 on it, right? So make sure you're paying attention to that. All right, sometimes you don't start with the short leg. Right here, I don't know what my short leg is. I want to know what it is. They gave me the long leg. My long leg is 12 square roots of 3. What was my short leg? 12. What's my hypotenuse?
24.
Okay. The next one, in between my 90-degree angle and my 60-degree angle, is my short leg. They gave me my long leg. If my long leg is 15 square roots of 3, what is my short leg? 15. What's my hypotenuse? All right, this time my short leg is here. My long leg is 21. 7 square root of 3. So that way when you multiply it by 3 to get to the long leg, you're at your 21.
Oh,
Okay? We just divided instead of multiplied. So 7 square roots of 3 is my short leg. What's my hypotenuse?
42.
What's my hypotenuse? You just double the short leg.
Oh, yeah, 14.
14 square roots of 3.
MJ.
All right. Shh. All right, on the next one, my short leg is between the 90 and the 60. They gave me my long leg is 24. What's my short leg? Right, because we divided out. If you want to see what that looks like, because we haven't actually looked at it, remember this is really in the formula x square root of 3 gives you your long leg. We solved that yesterday on our notes. How do I get rid of the square root of 3? Divide it out, right? So then I end up with x equals 24 over the square root of 3, but I'm not allowed to have that. So I multiply the top and the bottom by the square root of 3. We did that yesterday. Which gives me 24 square roots of 3 over just a 3. 24 divided by 3 is? 8. Okay, so there's the math behind just dividing, right? You're dividing out that square root is what you're doing. Okay? If my short leg is 8 square root of 3, what is my hypotenuse?
16 radical 3.
16 square roots of 3. Okay? All right, the next one, I have a 60 degrees to my 90 degrees is my short leg. My long leg is 19 square root of 3. What's my short leg? 19. What's my hypotenuse?
38.
Okay. On the second one here, my short leg between the 90 and the 60, they gave me my long leg is just 18. There's no square root of 3 to take off. So what do? Divide by 3, I get 6 square roots or radical 3. What's my hypotenuse? 12 square roots of 3 or 12 radical 3. Okay. 7 square roots of 3 is my long leg because my short leg is between the 90 and the 60. Bless you. If my long leg is 7 square roots of 3, what was my short leg?
7.
Just a 7. Just take that square root of 3 off. What's my hypotenuse? 14. All right, and the last one in this section, if my long leg is 12, there's no square root of 3 to take off. So what do?
4 radical 3.
How did you get the 4?
4 times 3 equals 12.
Right, divide by the 3, so you get 4 square roots of 3. What's my hypotenuse? 8 square root of 3 or 8 radical 3. Double your short leg. All right, sometimes you're starting with the hypotenuse, right? So in each of these we can see I'm starting here with the hypotenuse. Okay? If my hypotenuse is 12, what is my short leg?
6.
6. What's my long leg?
6 radical 3.
Okay? If my hypotenuse is 14, what's my short leg?
7.
What's my long leg?
7 radical 3.
If my hypotenuse is 10 square roots of 3, what's my short leg?
5 radical 3.
And what's my long leg? Yeah, you take the 5 square root of 3 and you put another square root of 3 on it. What does that become? 15. Okay. All right, and then the next one. My long leg, or my hypotenuse is 8 square roots of 3. What's my short leg?
4 radical 3.
4 square roots of 3. What's my long leg?
12.
12. Because again, it's 4 square roots of 3, square roots of 3. The square root of 3 is canceled to just a 3. 3. All right, the next one, my hypotenuse is 18. What's my short leg? 9. What's my long leg?
9 radical 3.
The next one, my hypotenuse is 24 square roots of 3. What's my short leg?
12 square roots of 3.
12 square roots of 3.
4 radical.
What's my long leg?
36.
Good. Okay. My hypotenuse is 25. What's my short leg?
12.5.
What's my long leg?
12.5 radical 3.
Did Miss Bishop make a typo on the next one?
Yes.
No, she didn't. I meant that. You thought it was a typo because I'm really good at typos, but I know I meant that, okay? Yes, I did. Because I want you to see how it works if you have a square root that just clearly doesn't belong, right? Because all our square roots today have been square root of 3, and then I've got this random square root of 2, okay? So, if my hypotenuse is 20 square roots of 2, what's my short leg?
10.
10 square roots of 2, because you just divide it in half. Okay? Then we say,
10 times 2.
yeah,
So we do 10 square root of 2 times the square root of 3, and that's 10 square root of 6.
perfect. So you do 10 square root of 2 times the square root of 3, which is 10 square root of 6. Very good. Okay? All right, what I want you to do now, if you have your journal, I want you to open your journal because we're going to make ourselves a little, cheat area of how you can help yourselves just referencing that rather than having to look inside the whole notes. So in my notes right above, I just did 3 right triangles that looked like they had a long leg and a short leg. And then I labeled my short legs with short leg. And my long leg with long. And then my hypotenuse. Okay? Then what I'm going to do is on my first triangle, I'm going to put the pattern. The pattern, remember, your short leg is X. I'm going to use a bigger point. Okay? Your hypotenuse, how do we get to the hypotenuse? 2x, we double it. And then my long leg?
X to the square root of 3.
X square roots of 3. And then you have 2 options. The way you're going to see them 98% of the time, unless you have a weird square root of 2 situation going on. Okay? So you'll either have just a plain old number down here like a 5. Or you'll have a number like a 7 with a square root of 3. That's generally how it's going to look. Okay? So if your short leg doesn't have a square root of 3 on it, then that means neither does your hypotenuse. They match each other. They either have them or they don't, right? If it does have it, then so does your hypotenuse. The long leg is the one that's always different. Okay, if your short leg doesn't have it, then your long leg's easy because you just stick it on there. If your long leg, or if your short leg does have a square root of 3, then you just need to multiply it, and so you end up without a square root of 3 because you would just end up with a 21. Okay? This is the sort of thing, if I was going to make a note card for the next test, I would probably put these 3 triangles on there so I can see if my short leg or my hypotenuse don't have anything on them, what the pattern looks like, or if they do have a square root of 3 on them, what the pattern looks like. That way I can see with actual numbers rather than just the rule.
Mind if I
Okay.
swim?